anyways, it's fine. Azure account, free trial,
Even when I closed the cluster on their last.
free trial. One per customer, pay as you go. Fine. All right. Welcome back. Now I have to pay.
Just pause that for him.
I don't care. Let's look at fake credit card. Oh my God.
Yeah, that's the problem.
Basic. No tech support. Please, no tech support. Upgrade, upgrade, upgrade. Review budget, go to budget, billing account, monitor, billing details. Oh my God. Billing, invoices, payment methods. Place, default, credits, view eligible credits. Need to get more credits. All right. Anyways, let's do it. Going back.
Instance. See that report.
VM. Don't have a subscription. I do have a subscription. Do I have to create the subscription now? Oh my God. Add. Review. Create. Create the damn subscription.
Done.
All right. VM. I totally have a subscription. Maybe it hasn't updated yet. Subscription.
What?
I just created it. I need to set it here. Let me just try refreshing this page. There we go. Create VM. All right, we're here one sec. We're running this thing, right? How much memory is this thing taking? Docker, dashboard, Docker, resources,
Well,
and it doesn't tell me.
oh,
It's okay, there's a way to do it. Docker stats. All right, we're using 5 gigs. So we're gonna need 8 gig instance. Okay, so she named test scalar LM new group. That's fine. That's fine. That's fine. 32 gigs? No. See all sizes. Memory optimized. General high memory needs. Oh, they have a lot of memory. Whatever. What region am I in? US East. Okay. Just give me the cheapest possible one. Compute intensive, high memory, general purpose. Let's just do that. RAM. You don't have anything lower than 32? There's no way. That's not cheaper. That's confidential data. F, N, other,
L8.
No. Oh, wait, look at this. 8. There we go.
Mhm.
General purpose. All right, how much? 60 bucks a month or 100 bucks a month? 60 bucks a month. Cheapest one. Okay. Let's do it. SSH key, new key, existing key. Give me a key. Cat.
Okay. This is a lambda key that you're posting.
I don't care. SSH disk. We need enough disk space. How big is this thing? Let's just make it bigger. 100 gig. Okay, 100 gig. Um, whatever. Next, networking. I don't care. I'm gonna run everything locally. Next, no monitoring, nothing else. Just create. Create the VM. I'm on VM. Come on, VM. Slow as all hell. All right, validation passed. You have SSH. Okay, fine. I know my ports are open to the internet. It's the whole point. I want to be able to connect to it. It's a test machine. All right, deploying. Okay, let's look at this thing. What happened? Okay, our test passed locally. Wonderful. All right, is it deploying? God, come on. Uh, okay. They're changing their UI. Okay, doing something. That's the deployment. I want to look at my VMs. No VMs yet. Deployment is happening. Doing stuff. IP, VNet.
That's probably the virtual
That's
machine.
probably the virtual machine. Yeah. All right. Deployment is complete. There it is. Wonderful. Okay. Let's make sure I can get to this thing. Um, IP address. I think this thing is called Azure user. So I can do um, keys, lambda, Azure user at that. Yes. Great. All right. Now,
I
yeah,
would build, actually would pull a container and
I want to eventually pull the container, but I've never tested this x86 thing in a long time. So let's just make sure that this thing is good. Okay. Clone, ScalarLM, ScalarLM. All right. I probably don't even have Docker installed on this thing, right? Let's look at this. Ubuntu install Docker. This thing install Docker. See, this is why I'm recording everything. I really feel like I'm gonna have to like play out this whole thing and just like edit out my credit card information, you know? Okay. So here we go.
okay.
That's got all the repos. Now we gotta get the Docker itself. Okay, so we're gonna install. Okay, does Docker work? No, it's got this like permissions thing. So let me do Docker permission denied Ubuntu. Normal user is this thing, and then it still won't work. So I have to log out and I have to log back in. ScalarLM Docker. Great. Okay, now Docker's working. So, um, let me just go through the whole build process. Okay, so we're gonna do ScalarLM build image, and then it'll just build for the CPU if I do build image. Okay, so we're just gonna. That's a good question, but I believe that the default is gonna build for the machine that we're on, in which case it's gonna build for x86. But we'll verify that. Where is it? Yeah, Linux AMD 64. Yeah, I don't even remember how it figures that out, but let's go look. Build image. Build image is going to check. Yeah. Okay. All right, so it's going to build. Might be a great time to look at the Docker container as part of the video. So we're going to look at our Docker file, and we can look at our CPU base image. So we're going to do Ubuntu, and then we put Python, and then we put in MPI. This is for distributed training, not that you'd ever use that on a CPU, but just so the libraries are there. Um, we install on this version of PyTorch because it's an old version of PyTorch, but that's the one that this version of v0.81 is built against. We install PyTorch, and then after that, we're going to move into this one where we build v0.81. We have a lot more dependencies for building v0.81. And then, and I think this is the main part of v0.81 where it builds it. We're not quite there yet. We're still installing the VLLM build requirements. That's what that's doing. Um, one of the risks of building this image is always running out of memory because compiling like all of this stuff takes a bunch of memory. So hopefully, like this instance that we got that only has 8 gigs of memory doesn't run out of memory. But, you know, we'll hope for the best. Sometimes the instance that we need to build is smaller than the, or sorry, bigger than the instance that we need to run on, which is annoying. So while we're doing that, I'm also going to just do this other machine, just in case. Though that terminal's broken somehow. All right, yeah, it's not working. Use my little local workstation. This is an x86 machine. I'm gonna do scalar LM build image on here. So one of these is going to succeed. Yeah, exactly. Okay. Where were we? Back over here. Now we're into the VLLM build. This is the dangerous one. We're running out of memory. But hopefully building on the CPU doesn't take that much memory. You never know. It's only building these like core libraries. These are all of the ops that are like custom torch ops.
Okay.
that it uses for inference. It kind of puts them in these libraries. So this is something that can fail. Like if any of these things don't build for the right GPU version, then when you try and start the server, it will fail to find them. So it's helpful to look at these things, not for the CPU build, but we'll do this later for the GPU build. We need to make sure it's like,
that 3 hour build I had when I was doing the Rockman build.
yes, in if you build on the GPU and then you have to build all of the dependent GPU libraries, you have to compile on the order of 20,000 kernels. Imagine that this number is not 10, but 20,000. Yes. And we have to do that on any GPU target and on any GPU family. So if you're on a T4, you have to compile a different set of kernels than if you're on a A100 or an H100 or an MI300. They all have completely different set of kernels. Um, so it's important to make sure that those in these builds that you're getting the right versions that match your GPU.
If Snowflake gives you an access to like some GPUs, you will use those to build it because the system is so weird, or do you prefer like a tensor wave equivalent like Crusoe or whatever to build get all this build stuff ironed out?
Um, you can build on any machine. Like you can build the NVIDIA
I know, but like
build on any,
yeah,
like I would not build on the deployment machines.
right. My question is like, let's say Mohan gets you some NVIDIA machines, but now you have to go through the whole SPCS environment to like a backhanded way to build this. Then how will you even, is it even
We
useful
need
for you?
build machines in addition to deployment machines. But we can use VMs, like this kind of a VM could be used as a build machine. It just has to be like a big build machine that can compile 20,000 kernels. Running the compiler doesn't run on the GPU. It builds for the GPU, but it runs on the CPU. So all you need is a really giant machine with a ton of cores and a lot of DRAM in order to be able to build. But the thing that's important to think about when you're doing deployments is if you're building the wrong versions, if you're
Yeah.
building for the wrong GPU, then you're going to come up with an image that can't run on those GPUs.
So now slowly we have to do like Greg, GDimus, Cray, Dash, NVIDIA, T4, like that, right? To
Ideally, what we'd do is we'd have a mega image.
I know, but then that's the fat binary thing that they're complaining about the 50 gig.
Yes, so you can either have a fat binary mega image that compiles for every single possible NVIDIA GPU.
Yes.
Um, Now that would bloat the container size pretty hugely. Like that would be a, you know, I don't know, 70 or 80 gig container.
Yes.
Um, so you may not like that. You may instead want like one container for each GPU version. But then if you make a mistake, like you accidentally, run it on the wrong GPU or you like use the wrong version, the wrong GPU SM version, then it won't work. It will crash and the error messages are not easy to understand when they crash. Um, okay, so now we built it and look, it succeeded. Great, so let's just do this. Docker, tag, that, times, scalar LM, CPU, v0.
x86, no?
Um,
Or you don't care.
so now I gotta log in order to do this. Log in, GUGS. Now we can push.
What's the latest?
Yeah, I do have to do one at a time. At least the internet connection in Azure is pretty good. Yeah, these CPU containers are not that big, thankfully. See if my other build finished. Nope, still building.
That machine is slower than the one we just provisioned? That seems
No, I just started it later.
mm.
So thankfully 8 gig was big enough to build the CPU container. That's one of the other gotchas when you're doing this is like you don't want to allocate a giant VM because you're going to pay a lot of money for it. At the same time, if you don't allocate enough memory, it's some aspect of this isn't going to work. Like you try and run a model that's too big, it'll run out of memory, or you try to do a build with too much concurrency. and too many compiler processes that are going to run out of memory. Um, so thankfully, 8 gig seems to be enough for the CPU build. Now, I strongly believe that 8 gig is not going to be nearly enough for the GPU build. It runs bigger models, and also the GPU kernels, there's more of them, so it takes more memory. All right, so there was that. It built, it pushed. Let's do our tagging. Tag latest. The push should be fast. Okay, so now we got that. So now let's get our same little, let's kill that thing over there. Let's get our same little command. Mm-hmm. Okay, we're just going to do CPU. That. Okay, and actually before I do this, because I'm logged in remotely over SSH, I'm going to use screen to just create like a ScalarLM background process so that I don't have to like keep logging in over and over again. All right. Wait a second, sorry. My copy paste was wrong. I should have done CPU. Okay, so there's that. So now we're just going to look at the logs here and make sure that this thing comes up okay. Okay. All right. So now once it gets here, this is good. Heartbeat successful is a good thing. Um, Now, another thing to keep in mind is when it's booting up, it's allocating memory for inference. When it says like got this many blocks, as long as it got more than 0 blocks, that means it can do inference. Sometimes if you don't allocate enough memory, like your GPU doesn't have enough memory, or you request too big of a model, or you request too big of a sequence length, then that thing can have no buffer, no allocated, it can't find enough memory to allocate the KV cache so that inference works. Um, and so it can crash there. So it's important to look at that number that we just saw and make sure that that's more than 0.
I know there was like a 95% usage of GPU for VLLM that can be set through the values.yaml file.
It's the same thing on the CPU. It just uses CPU memory instead of GPU memory. All right, so we exited out of our screen. It's still running in the background. We can go back into it and verify it's still running. Let's exit out of it. So now let's do our tests.
Yeah.
Okay, so I'll just do it in the same directory. So let's just do Python. I don't even know what Python is installed on this thing. Let's make a virtual environment. Don't have virtual environment installed, so I'm going to install that. It's fine. Source, virtual environment, activate. All right, install ScalarLM. Make sure it got it. Got this one. These versions of ScalarLM should be mostly compatible with each other, I would say. There may be some inconsistencies, so if you see any inconsistencies, you should see like it's called ScalarLM, version equals 0.0.81, for example. Most of it should be compatible. There may be some small differences. Okay, in this case, I think this is going to work. So anyways, let's make sure we're all set up. ScalarLM help. We're going to do the same thing again. Help. Do that. It worked. We can do ls. We'll see if that works. It looks like it worked. Um, okay. And we can go into our little screen and verify that it got that request. It got list models. Okay, so we hit the right server. Okay. So now let's do
Python path. Oh, you don't need to.
yeah, I think we can just do Python deployment. We're gonna start with health. Health is up. Generate. That worked.
Train reduce the iterations or data set size and then.
Yeah, let's look at okay. Test deployment. It should be faster, but you're right. Here, let's do this. Data set size not times 100. I'm gonna check this in also, by the way.
Mm.
All right, GPUs not to. No GPU parallelism on a CPU. Not a good idea. Um, all right, we're running against localhost. Okay, so I'm gonna check this in, but I can't because I'm not
It's okay, you have it set
authed.
on.
Let's just do it here.
You have it already in your local.
This is my local.
See, you have it. You did it already.
I just want to make sure. And I'm going to do test train generate too. It's too many iterations. Oh, maybe we needed that many iterations to get it to converge. That's possible. Okay, I'm just going to leave it. Something like this, I don't care. I'm just committing directly to main. One GPU and train. Um, okay. So where did we go? We were back over here. And now we can try running this. The training test. Submitted it. Use SQ, make sure it's running. I'm gonna do LSA, watch, and oh, see it completed instantly. Look at that. 4-second training time. Let me look at the logs for that one. That's how it should go. I think just the Mac build is like, must be using the wrong CPU library or something. See, that's what it should be. But whatever, it doesn't matter. Perf on the CPU is not something we care about at all. So we'll watch it and just make sure it gets deployed. True. Okay. So now we'll do one more test, deployment, train, generate. Okay. So that is running, training. Should be much, much faster because of the
X86.
yeah, okay. So now it finished training. So now it's waiting for deployment. At some point, I'm gonna fix this deployment thing so it deploys on like a push basis instead of polling, and it should be more immediate. But I think at this point, if a training job takes an hour, people are willing to wait 10 seconds. Yeah. All right. Great. Ran and it worked. And we can also use my ScalarLM stats and look to see that we ran 3 requests, 250 tokens. And see, our perf was like pretty god awful in all honesty, 2.6 gigaflops, but you know,
What is it
150
again?
tokens per second. It's like 1,000 times faster. But it's also a much bigger model and so on. Don't beat up the CPU too much. Anyways, that was it, I think. Like, I think that was everything, right? I just want to, next, I want to see if people can go through and do this. If they can do this, then like, you know, this is like a sane state for local development and like one remote development. Okay, and before we do it, before we exit, we gotta go back, sorry, into my block. This thing, VM. Kill the VM. VM. How do I kill it? VM. Stop. Delete. No, I don't need to force delete. Delete, delete, delete. Oh, they're making this stuff better. Delete, delete, delete.
Stop recording. Or is there anything else?
No, I think that's it. Let's, okay. Where's my recording? More. Pause.